Hi, my name is Rich Edelman, and I'm going to talk to you about being smarter than your test bench. So are you smarter than your test bench? A lot of ways to get smarter is to add UVM info into your test bench. So you add UVM info and you put in information, outcomes, log messages, and you're smarter. The problem is you might have gotten slower too. A lot of people put these UVM info messages into their high-speed monitors. So they got a high-speed clock going really fast. It hits this UVM info and they say, well, I know how to fix that. I'm going to make it UVM high. Well, the problem with UVM high is it still goes inside here and checks to see should I print a message or not. And that's actually a lot of work, especially on a monitor with a high-speed clock. So I'm proposing what we need to do is have an extra check here in the top that says, well, if it's medium or high, just get out. Don't even go check. So that'll be a lot faster. In my experiments, a lot faster. So you want to put UVM infos in for sure, but you want to make sure that you don't get slow when you do. What else can you do to be smarter than your test bench? Well, we have some macros here that you can put in, and you're marking very interesting places where you want to track your transaction. So this is the driver, and right after get next item, we've marked that as an interesting place. Right before ap.write, we've marked that. Over here in this monitor, we've also marked a place over there. Down here in my scoreboard, I've marked a place in the write routine, in this calc routine, down in the run phase after we pop things out of the FIFO. So we have all these things marked, and then what we can do is we can ask for a report to say, where has this transaction been? And then this whole list will come out. We'll get the time it went in, its name, file and line number, where it was marked. We'll get the system Verilog or Verilog context. We'll get the UVM context. So we can see here, this particular transaction at time 2570 at line 80 was constructed. So at line 80, it was right here, it was constructed. And so this is a very nice report to tell you where your transaction has been. So that's these red macros that you see around here, and they are new code that you might add to your test bench. There's other macros in here to help you be smarter than your test bench. For instance, this one, create object. So instead of calling : create, you call this create object macro, and that's going to keep track of all the sequence items that you generate. And when you run and get a report, you'll get a report that shows you where things were created, either by file and line number, or by the full name in the UVM, or by the sequence item type that you were creating, or from the sequence from which you were creating it. So for instance, you can see here, in this case, there's 3 different sequences. One of them created one sequence item. Well, that's a dump sequence item, so that's a special case. But you can see that there's one sequence here that created twice as many sequence items. Maybe that's a bug, maybe that's okay. So this gives you a little more visibility into what happened. You can see that, up here in this sequence, there was only one thing that happened. Maybe we need to investigate that. So that's another way you can be smarter than your test bench. Another thing you can substitute is start item. So instead of start item, you say tick start item. Now what that's going to do is that's going to register that item, that transaction, as active on your driver. And then you can ask for a report later that's like a load average, just exactly like top or uptime does on Linux. You see the load average on your driver. So these are different agents, different drivers, and you can see the load average is 6. Well, and they all look like they're about 6. That's probably okay. But if one of them was 26, maybe that's a problem. There's some transactions that haven't got processed by the driver. So with a little bit of instrumentation, you can be smarter than your test bench. The red stuff is the new stuff. The black stuff is just a substitution. You can get into that habit of putting in this kind of code, and of course you can compile it off if you're not using the debug part. We have one more substitution you can do, which is to start a sequence. So instead of sequence.start, you do tick start sequence. And that's going to give you a report, you can imagine, on all the sequences that you started, how many you started, and the last time that they were started. So this system is maybe 4 pages of system Verilog code. There's macros. Each of these macros is 2 or 3 lines long, and the data structures that it builds are just system Verilog data structures, pretty easy to understand, basically an exercise in associative arrays and queues. So this source code is available, and you can get it from me no problem. Thank you very much.